Dear students, in this lecture we will derive Rayleigh Jeans law from Planck's law of radiation. In the previous lecture we have derived Planck's law of radiation, that is rho of nu d nu is equal to 8 by h nu cube by c cube into 1 by e power h nu by kt minus 1 into d nu. This equation is in the terms of frequency. For its applications, we can change this terminology into wavelength. For that, we will use nu is equal to c by lambda, where nu is frequency of the light or radiation, c is the velocity of radiation, lambda is the wavelength of the radiation. By differentiating nu is equal to c by lambda, we will get d nu is equal to c is constant, we will keep it as it is. 1 by lambda is variable, then if we differentiate this, we will get minus 1 by lambda square into d lambda. Here I have neglected negative sign because wavelength is positive since it is having dimensions of length. Therefore, substituting for nu and d nu in the expression of Planck's law, we will get rho of lambda d lambda. It is equal to 8 by h divided by c cube. I have written as it is. In the place of nu cube, I have substituted c by lambda whole cube into 1 by e power h. In the place of nu, I have substituted c by lambda into kt minus 1. In the place of d nu, I have substituted c by lambda square into d lambda here. If we simplify this, c cube gets cancels. 8 by h c will be left in the numerator, and in the denominator lambda cube is there, lambda square is there. If you multiply them, we will get lambda to the power 5 into 1 by e power hc by lambda kt minus 1 into d lambda will be left. Then finally we will get Planck's radiation law in terms of wavelength as rho lambda is equal to 8 by hc by lambda power 5 into 1 by e power hc by lambda kt minus 1. Using this expression, we will derive Rayleigh Jeans law, Wien's displacement law and Stephen's law. Now we will derive Rayleigh Jeans law from Planck's law. For that, I will choose Planck's radiation law in terms of wavelength. I have written u lambda for energy density instead of rho lambda here. U lambda d lambda is equal to 8 by hc divided by lambda to the power of 5 into 1 by e power hc by lambda kt minus 1 into d lambda. Now I will use series expansion of exponential term which is in the denominator of right hand side. We know that from our series of exponential function e power x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. up to x power n by n factorial. I will use this power series in order to expand e power hc by lambda kt. It can be written as e power hc by lambda kt. It is equal to 1 plus hc by lambda kt, that is x is equal to hc by lambda kt here, plus 1 by 2, 2 factorial is 2 into hc by lambda kt whole square plus 3 factorial is 6, 1 by 6 into hc by lambda kt whole cube plus etc. Since lambda is in the denominator, Rayleigh Jeans law is applicable only in the longer wavelength region. That means lambda is very large here. Since lambda is very large, hc by lambda kt becomes very small. If hc by lambda kt is very small, its square, cube, fourth power, fifth power or nth power are very lesser than hc by lambda kt. Therefore, we will neglect higher order terms from second order term. We are left with the 1 plus hc by lambda kt. If we substitute 1 plus hc by lambda kt in the place of e power hc by lambda kt in the denominator of RHS. We have 1 plus hc by lambda kt minus 1. 1 minus 1 becomes 0. hc by lambda kt becomes lambda kt by hc. hc gets cancels. Lambda power 5 and lambda gets cancels. Lambda power 4 will be left in the denominator. Therefore, we have u lambda d lambda is equal to 8 pi kt by lambda power 4 into d lambda, which is the required Rayleigh Jeans distribution law. It can explain all the properties of blackbody radiation at longer wavelength region.